Hi, let's solve the second question from today's weekly contest, that is find the largest area of square inside two rectangles. So there are n rectangles in a 2D plane and you're given 0 index 2D integer arrays bottom left and top right of size n each. And bottom left and top right is what? They represent the bottom left top right coordinates of the ith rectangle. Okay. And you can select the region formed from the intersection of two of the given rectangles. You need to find the largest area of a square that can fit inside this region if you select the region optimally. And then you need to return the largest possible area of square or 0 if there do not exist any intersecting regions between the rectangles. Alright, so let's understand what the question is. You're given bottom left and top right coordinates of the ith rectangle like this, right? So see, this is the bottom left and this is the top right corners. So this and this, right? For the 0th rectangle, these are the coordinates for bottom left and top right. So this is how the arrays are given to us. And then what we have to do is we have to check for all these rectangles, right? This is the, so here three rectangles are given to us. For all these three rectangles, they can have some intersecting points. So in this figure also you can see this is the first rectangle, that is from 1 comma 1 to 3 comma 3, that is given here, right? And then you have the second rectangle, this blue one, which starts from 2 comma 2 here bottom left and goes up to 4 comma 4 top right corner. So this is the second one. And the third one is colored green here, which starts from 3 comma 1 and 6 comma 6. Now you can see there is some intersection. So here is this one intersection point part, right? This particular area you can see, and this particular area. So these are the intersection of all these three rectangles. Now out of this intersection, right? So you compare first two rectangles, right? And you have to tell the square with the greatest area, right? So here, see, you have this square, correct? And you are going to have some common area from the intersection of these two. Now inside of that common area, you need to take out a square, right? So you have to have a square which fits in this intersection, and you have to compare all the rectangles that you have, their intersection, and you have to tell what is the maximum area that you can get, right? So here in this case, if you see, so this is the intersection point, correct? So for this square, if you see, this is 2 comma 2 and this is this would be 2 comma 3, right? So the length is 1 of this square, and this is the whole intersection is actually a square. So what is the area? It is 1. Now let us go and check for the second possibility. So see, now the first rectangle and the second rectangle, that is the blue and the green one, are intersecting, right? So but the intersection is a rectangle, right? Now in the question it's mentioned you have to take out the square from this intersection, right? So what is the square? The square you can see is this, right? This particular square you can consider, or this square you can consider. So out of those, what is the maximum area? Maximum area is, again, see, this is 3 comma 3, this point would be 3 comma 4. So the side of the square is going to be 1. So again the max area, see, the area you're going to get here is 1. The area you got here was 1, so the maximum area is going to be 1. Now among red and the green one, there is no intersection, so we cannot take out any area. Now let us go to the second one. So in the second one also you have three rectangles, right? These three rectangles, again with three colors they are shown: red, blue, green. So among red and blue, if you see, right, among red and blue, what is the intersection? The intersection is whole of this, right? This whole rectangle you can see here. But the square, right, we have to consider a square. So a square is going to be of side 1 only, so you can take out two squares, right? Similarly, you can see that blue and green are also intersecting. Where are they intersecting? So blue and green are again intersecting here, correct? They're intersecting here. And then we are trying to get some area. This is a rectangle, but again you need to get a square out of this, right? So the square is going to have one side. Similarly, if you see among red and green, there is a common area, that is this particular. So a square is formed here, right? So this is square. What is the area? It's going to have 1. So here also the maximum is going to be 1, right? So now in the third test case, if we see, right, there is no intersection point, so there is going to be nothing, right? Now I hope you have understood the question a little bit. Let me draw these rectangles again here, right? Let me draw the coordinate axis. 1, 2, 3, 4, right? Now for the first rectangle, we have 1 comma 1, 3 comma 3, right? So let's take red, okay? So from 1 comma 1 to 3 comma 3, we have one rectangle, right? Draw it like this. Okay, then the second one is from 2 comma 2 to 4 comma 4. 2 comma 2 is here, right? And where is 4 comma 4? It's here. Okay, let's draw. Okay, now we have the third one. We draw it with this 3 comma 1 and 6 comma 6. So where is 3 comma 1? 3 comma 1, that is this corner right here, and 6 comma 6. We haven't drawn that. 6, oh sorry, 5, and this is going to be 6. 5 and 6. So it's going to be here, all right? So this is going to be common area. All right, right? So this is the three rectangles that we have. Now what you have to do, you have to tell the largest area square, right? Now see the intersection. Let me draw the intersection with gray, okay? So the intersection is here. Here you can see the intersection. Quite a light color. Just draw with yellow. This is the intersection that you can see here, okay? Then, so this intersection, yellow one, is among red and blue one, okay? And let's draw with, let's take this. So this intersection that I'm drawing with purple is between the blue and the green rectangle. Now, among these two intersections that we have, see, we can have intersection among all the rectangles, okay? But here we only have intersection between the blue and red and blue and green. The intersection is among blue and red and blue and green, okay? We could have had the intersection between red and green, right? But anyways, we have only these two right now. Now I have to tell the maximum area of a square that we can have. So here for this square, if you see, so this is 3 comma 3, so this is 3 comma 2, right? So this is 3 coordinate, 2 coordinate, so length is going to be 1. So this is a rectangle, oh sorry, a square in itself, right? Now here you have a rectangle, right, with side 2 cross 1. Now in this rectangle you have to find the square. So square is obviously you have two length, right? So if you cut short it by whatever is here, right, that is the minimum out of these two, that is length and breadth of the intersection area, right? If it is a rectangle, so you take the minimum out of that, so you get 1 here. So 1 into 1, you get 1, right? So here in this case, for this intersection, the maximum area, the area of the square that you're going to get is 1. For this also you're going to get 1. So the answer is going to be 1 itself, right? So I hope you have kind of understood the question. So now it becomes very easy from here. All you have to do is what? You have to iterate, right, in all the rectangles. Now in all the pairs of the rectangles, right, you can have some common area between these two, or between these two as well, right? So it's not like you have to iterate with this and this, compare like first two values, right? And then the, like, you don't have to take pairs inside of this array and keep comparing. Rather you have to take the different, combinations of the rectangles that you can have. So here you can have three, right? So you are going to iterate in all the intersection of these rectangles, right? Then so simply you will have to take two loops, right, from I 0 to n and j 1, sorry, I plus 1 to n, okay? For this, if you are standing with this, the intersection you can have with this too, correct? And if you're standing with at this, let's say there was another one, so you have to check with this, these two, right? So because this, with this you would have already checked, correct? So this is how you have to iterate. Then you have to check the intersection. How do you check the intersection? So you calculate points, okay? So intersection of what? The both rectangles. So you try to get the this intersection rectangle, right? Its coordinates, its bottom left coordinate and top right coordinate, right? You try to get that. So this how you're going to calculate. So let's say you have this square, right? And this is square. How you're going to calculate? The maximum among these x values, correct? The maximum among these x values. Maximum what? Bottom left, right? You want to get the x coordinate. So I'm calculating x1 as maximum of bottom left of what? I, right, comma 0, and bottom left of j comma 0. So you're trying to get the x coordinate. Similarly, get the y coordinate, right? So y1 coordinate, how are you going to get? Now, y coordinate for bottom corner, right? So again, you have to calculate the max. Now, why are we taking max? Because it is the bottom, right? It is the bottom corner that we are comparing. And see, the constraints are like this, that is, they're greater than 1, right? So if they're greater than 1, that means you are always going to be in the first quadrant. That is, you do not have any negative coordinates. So if you don't have, so you can safely apply this max operation. So you have to get the maximum out of this because you want to get the intersection. Similarly, for the top right, you're going to calculate the minimum. So from this and this, what is the minimum one? This is the minimum, correct? So that you have to calculate. So from this, you are going to get the intersection, right? So you are calculating x1, y1, that is for the bottom corner, bottom left corner. What are the coordinates? They are x1, y1. For the top right, what are the coordinates? X2, y2. So you calculate like this, okay? So here y1 is going to be maximum of bottom left of I comma 1, right? And bottom left of j comma 1, right? This is the y coordinate. Then x2 is going to be the minimum out of what? Minimum out of top right of I comma 0 and top right of j comma 0, and y2 is going to be the minimum of top right of I comma 1 and top right of j comma 1, right? So after you get this x1 y1 and x2 y2 coordinates, your next step is to check if there is actually any intersection. So how are you going to know? See, bottom left should always be less than top right, correct? This coordinate should always be less than top right because it is it is the bottom left corner and is the top right corner. So you're going to have some area when you have bottom left corner less than the top right corner, only then, correct? So you simply check if x1 is less than x2 and y1 is less than y2. If this is true, only then you're going to have some intersection. So after that, you get some intersection area. Now out of that intersection area, now you have to calculate the area. How are you going to calculate the area? So you have to simply take the minimum. See, as I said, you can get a rectangle, right? If you get a rectangle as intersection, you need to get the square, right? In the question, you need to return the area of a square and not a rectangle. So that you're only going to get, let's say you have x2 minus x1. So that is 1. Then you have y2 minus y1. That is 2. So the square is this only, right? So if the square is this only, so you have to get the minimum out of these two values. So the side of the square that you are considering is going to be minimum of x2 minus x1 comma y2 minus y1. And then you can simply store it in, let's say, max area variable, and you can simply store side into side, right? So maximum of whatever you have already stored. So this is the whole logic of how to solve the problem. So I hope you have understood it. What we are trying to do is we are trying to iterate in all the rectangle combinations, that we are considering all the pairs, and then among all these pairs we are calculating the common intersection, right? The common intersection among both the rectangles, and we are calculating what? The bottom left and top right corners of those rectangles, of that rectangle, that the intersecting part, okay? After that, we're simply checking if the intersecting part exists. How? If x1 is less than x2 and y1 is less than y2, only then there is going to be some intersection part. So if we have some intersection part, we have to get the side. Now the side is definitely going to be the lesser value among the difference x2 minus x1, y2 minus y1. We already saw y. And then you have to simply get the area. So that is the whole logic. So let me show you the code. See, now the code here is you take max area, initialize it to 0, right? And you take n. So n is the size of the, like n are the number of rectangles that you have. So you can get either from top right or bottom left array. After that, you are iterating in all the rectangles and you are checking the x1 y1. This is the x1 y1 is the bottom left corner of the intersecting part, and x2 y2 is the top right corner of the intersecting part, right? So as I said, bottom is going, you are going to check the maximum, right? Because you are going to check the intersecting part, right? And for the top right, you're going to check the minimum. And then you are simply checking this condition, right? If there is the intersecting area, then calculate the side. So its side is going to be minimum on this, and calculate the area, and then return the area. So that is the whole logic. Now, talking about the time and space complexity, time complexity is going to be big O of n square because you are considering all the possibilities, and the space complexity is going to be big O of 1 because we are not consuming any extra space.